Hello everybody, I'm meteorologist Don Day, and what we're going to do with this video is going to give you an update on solar activity and how it may impact our weather and climate. Kind of give you a discussion on things we've learned, things we don't know, and things going forward that may give us some clues on what's going to happen with our overall general weather trends and climate trends as we go through the rest of 2021 and into 2022 using the solar influence kind of as our perspective. Now, before I get too deep into this, I gotta put up this warning slide because this sometimes makes people upset. This is not meant to be a man-made climate change debate video. Not at all. We're simply discussing the influence of solar activity and how it affects our weather and climate. There's a lot more we've got to learn. There's a lot we don't understand. Solar is only one piece of the puzzle. However, this has to be said, and this is why I'm putting this warning on here, the Earth-Sun, and really the Earth-Sun and space connection with our weather and climate is largely ignored by current climate science. In fact, it's maligned by many areas in the climate science field. So if you're of the opinion that it has no influence, that only greenhouse gases are controlling our climate and weather, such as the phrase that carbon dioxide is the control knob of our weather, well, this video is not for you. Just stop now. However, the connections between the Earth, Sun, and space activity, cosmic rays, and solar fluctuations is quite intriguing. However, do your own research. I'm not here to tell you I'm an expert. I'm just providing you with information from other experts and sort of how I look at things from what I have observed in 30 years of weather forecasting. Keep in mind, you're going to go online if you want to do your own research, but be careful. On both sides of the solar debate, whether you're for solar activity impacting our climate or against it, you're going to find a variety of different topics, different websites. You'll find websites dedicated to completely debunking the solar connection. You'll find websites that say it's only about solar activity. So be really careful with your search engines, being very careful with what you look at. There's some very well-made, well-designed websites that make it look extremely official that this is the only word on this topic, and that's really not the case. What I really suggest you do is do some reading that maybe is offline. That sounds very old-fashioned, but there's some books and there's some things you can do to get both sides of the story. Also, this video discusses the impact of solar activity mainly in Western North America. The impacts are global, but there are regional differences in the outcomes as well. So with that said, I think this quote by Richard Feynman really sums it up. Science is the belief in the ignorance of experts. Okay, no one's got all the answers, especially with climate. So we got to really step back and keep in mind, we got to really be careful not to be arrogant that we know everything about weather and climate, because we don't. But there are some interesting things that we're going to be talking about. First of all, where are we in the solar cycle progression? What I'm showing you here is the sunspot number and the progression of the solar cycles. Where you see this 25 here, this means we're entering solar cycle 25. We just got done with solar cycle 24. The red line is the prediction and the number of sunspots. And then, as you can see, this is where you have your solar maximums. This is where, on the bottom, you have your solar minimums. Well, what does that mean? What does a solar cycle mean? And what is a solar maximum? What is a solar minimum? Without going too deep into the weeds, a solar maximum is when the highest number of sunspot activity is found on the sun. The solar minimum is when the least amount is going to be taking place. These cycles are spaced apart about every 11 years. And if you were to graph sunspot numbers all the way back to 1750, they were really starting to be observed a century before that, but really scientifically written down and observed, it goes back then. And you can see these 11-year cycles going from 1750 all the way through present. And you can see there are some cycles that are stronger than others. You can see that there are solar fluctuations in the way things go on over time. And you will notice that we have some distinct periods of time when the solar activity was very low. The maximums were weak and the minimums were strong. This was a period time where the Earth was quite cool. Obviously, this is a period of time here when the Earth was very warm. Same with these periods right here. Also, a cool period in the late 1800s and into the early 1900s before we started to warm up. And notice the amplitude trend of where we are now. So these solar cycles are different every year, but there's also, over time, different fluctuations. Now, why are sunspots important? Well, the magnetism of the sun and the magnetic field from the sun will contract and expand. When you have a high number of sunspots, like we had here in 2001, the magnetic field of the sun expands and grows, and the Earth is protected from cosmic rays coming from not only our star, the sun, but from, well, the Milky Way, from the whole universe out there. Shooting across the universe are cosmic rays from other stars, from supernova explosions. These are highly charged particles that are shooting out across space. How does this impact, or how could it impact the weather? When you have a solar maximum like this and a lot of sunspots, you have a decrease in cosmic rays. The amount of cosmic rays hitting the Earth goes down. This is not debated. This is a very well-established scientific fact that less cosmic rays are interfering with our atmosphere and the Earth during solar maximums or periods of high sunspot activity. Conversely, when you have solar minimums, very few or no sunspots, okay, the Earth's magnetic field is not as strong coming out of the sun, and what will happen is more cosmic rays are hitting the atmosphere during solar minimums. Again, a well-established fact. So what will happen is that during solar maximums, we have more cosmic rays, less cosmic rays during solar minimums. When we have more cosmic rays hitting the Earth, there are some very intriguing studies out there, especially by a scientist called Svenmark, that says that increased cosmic rays hitting the Earth's atmosphere leads to more cloud condensation nuclei. Basically, the reaction of cosmic rays chemically and other atmospheric interference trends that happen as cosmic rays hit the upper atmosphere and the lower atmosphere as well, is that if you get more cloud condensation nuclei is what cloud water droplets will form on. Whether it's dust particles, there's other things in the air that will help a cloud form. The more condensation nuclei that are formed through these reactions of the cosmic rays hitting the atmosphere makes it easier for clouds to form. Now, flip that around. If you have less cosmic rays, you're going to have the tendency for less clouds. So this is a pretty well established and mostly accepted premise. Now, the debate is, well, how many more clouds form during solar minimums and how many less clouds form during solar maximums? Because if you create more clouds during solar minimums, because of increased cloud condensation nuclei, you're going to have a cooler Earth. The clouds aren't going to be trapping the heat, but rather knocking down the solar input and making the Earth cooler. This is especially true over the world's ocean basins, where these low stratiform clouds from this process tend to develop. If you have a solar maximum, you have less cosmic rays hitting the Earth's atmosphere, then what will happen is you have less clouds, and then the Earth can turn warmer. So the idea here is that cosmic rays don't control our climate, but could impact our climate during these solar fluctuations. Again, this is not to discount greenhouse gases, but this is an element, part of the climate picture, part of the climate argument, so to speak, the discussion of whether or not solar activity really helps or hurts when it goes through these cycles in terms of making the Earth warmer or cooler. The University of Oulu in Finland has been measuring the cosmic ray influx into the Earth's atmosphere since April of 1964. And if you go down here and look, what you will see is during solar minimums, like what we just went through, and if you go every 10 or 11 years back, you will see that there is an increase in the cosmic rays hitting the Earth during solar minimums. So you can see that these are evenly spaced out in the solar cycles. Conversely, cosmic ray activity decreases during the solar maximums. You can see back here, 91, 92, a really big dip in cosmic ray activity. Not only are cosmic rays coming from our sun, but from space as well. So that's important. There's things that could be happening very far from here that could end up impacting our weather and climate if this ends up being a correct premise. So we know this, it's measured all the time, and then when you put this all together, this is what you end up with. When you have a solar minimum, like what we just experienced in late 2019 and early 2020, you have lower magnetic field strength, fewer sunspots, less solar wind hitting the Earth, so more cosmic rays are hitting the Earth. That increases low-level cloud formation, that reduces sunlight, the Earth becomes cooler. Now, there's one way to say, well, we should be able to see this in the temperature trends, right? We should be able to predict if the Earth is going to get warmer or cooler based on these solar cycles. So this should be something that you can go back and see and be able to graph. Again, it's only one part of the climate discussion. It's not all of it. But if you were able to then take this idea and say, let's take the amount of cosmic rays right here, and if you were to be able to measure that against low cloud amount, again, we're talking low stratiform clouds that form in these situations. And you can see this graph is pretty compelling. You have an increase in cosmic rays, you have an increase in the amount of low cloud cover. You have a decrease in cosmic rays, you have a decrease in lower cloud cover. If you were able to then put this all together, what you should see during these solar minimums is that you should see a general cooling overall, not everywhere, but a general cooling in the Earth's atmosphere, then eventually the oceans. And if you go back in the last 12 months, during the peak of the solar minimum, we all have been talking about the La Nina and the cooler Pacific Basin. Well, you get these La Nina and El Nino cycles regardless of where you are in the cycles, but you do tend to see stronger La Ninas, and you tend to see a stronger general trend in cooling during these solar minimums. And the La Ninas in particular can be quite devastating, like we're seeing right now in the western United States. And to go back, why is this important? Because if there is, again, if there is a solar connection between the Earth being cooler and warmer, and then the water temperatures fluctuating based on these solar changes, well then if you get into a La Nina situation like we're in right now and have been for what will be by this later fall and early winter, almost 2 years, the western United States it's a drought signature. It's dry. Conversely, when you have solar maximums, you have a warmer Earth and you have warmer waters, because El Ninos, you get warmer water in the Pacific. La Ninas, you get colder water in the Pacific. Warmer waters in the Pacific make it wetter. Colder waters in the Pacific make it drier. This is why it's really important to start making these connections. Now, if we were to track where these La Ninas and El Ninos happened during the last 3 solar cycles that we've been through, it's pretty interesting. We do tend to see La Ninas form near the bottoms of these solar minimums. We tend to see the strongest El Ninos right after solar maximums. So again, no mystery here. The correlation is pretty strong. So by just using some solar history, you can have a good idea of maybe what's coming with these El Nino and La Nina cycles. Again, I have to stress this. It's not the only part of the equation. But this is something I think, especially for folks in Western United States, need to understand. That when we go through these solar maximums and solar minimums, the tendencies are there. During solar maximum, you have less clouds, less cosmic rays. It tends to be warmer. You tend to have stronger El Ninos, and it's more wet for the United States. In fact, those are the good water years, usually, during and after the peak solar maxima. You tend to get those El Ninos that are stronger. This is when you start to get the better rains in California. You tend to have some better snowpack years. You can tend to have better wet conditions during this period of time, as well as in parts of the Corn Belt and Midwest. Solar minimums are really bad because we tend to get cooler. We tend to have stronger La Ninas. These La Ninas tend to last 2 years. All I have to do is go back and look at historical trends in 1999, 2000, 2011, and 2012, and the most recent last 2 years here. It's no accident that each of these 3 2-year La Niñas, which were all severe western droughts, look at the spacing between them. They're all about 10 to 12 years apart. That is not by accident. That's just not a fluke. Solar minimums tend to produce stronger La Niñas, less rain, less snow, and higher drought tendencies. Now, there will be people who argue that, but that is what I have observed. And by making these cosmic rays connections, I think it's compelling. Again, it's not the final word. But what will happen during these solar minimums, which do tend to have a higher impact, especially when it comes to drought, is that you tend to have these things happen right here. And I want to talk about this right here as well. You get more amplified jet stream patterns and higher persistence. And this is something that we can really show you in fact, 3 really big examples about. Another thing that I need to bring up is that the amount of cloud cover, you may be asking, well, how much more cloud cover could form? Well, that's a good question. And again, that's debated. On the low wind, some papers say cloud cover increases as much as 2%, which doesn't sound like a lot. A recent paper says 6.8% increase in low cloud cover. But even a 2% increase in cloud cover will have a temperature impact on the globe. But let's go back to these more amplified patterns and higher persistence. This is when you tend to get weather patterns during solar minimums that get stuck, where you just kind of get stuck in a pattern that's either dry or cold or wet and hot. Somewhere in there you tend to get into these stuck patterns. And that is something that we have definitely seen during solar minimums. And also I want to show you that we have 2 graphs here. And one thing that you will hear some people say that the sun has very little impact on the climate when they use total solar irradiance, basically, which is the brightness of the sun, because the sun does go through these fluctuations of being brighter and dimmer, which does impact the output of energy coming from the sun. But if you were to stack up the solar impacts of irradiance and stack it up against these other features, what you find is that these other features are much more impactful than the brightness of the sun. So if you're only using the brightness of the sun as your climate input, well then you really run the risk of ignoring these other things that, as I'm showing you, we're observing. So this is what we tend to see. During La Niñas and solar minimums, you tend to have a higher tendency for blocking patterns. All we have to do in very recent history is go back to the February Arctic outbreak that caused all the power grid problems in Texas and the South. That was a persistent pattern that set up a prolonged period of cold where the jet stream was highly amplified, meaning the jet stream went all the way up through the Gulf of Alaska, near all the way up to the Arctic Circle, then took a giant dive due south all the way to the lower latitudes of the Gulf Coast. Now, the same thing we can talk about during the big heat wave that hit the Pacific Northwest in late June and early July. Again, that was a pattern where the jet stream got stuck. You had a big ridge build up along the west coast. You had a large trough develop in the southeastern United States, and you were allowing the heat to build up. The Russian heat wave in 2010, which a lot of people attributed to climate change, that was another situation to where we were in a solar minimum and we had a blocking pattern. You tend to see these blocking patterns not be so persistent once you get out of the solar minimums. So we could make a prediction that in 2 or 3 years, these extreme events will be less. They won't go away, but they will be less as opposed during these solar minimums. So I talked about, should we see temperature trends change? Should things change based on the influx of cosmic rays or the decrease in cosmic rays? Well, interesting enough, the global temperature anomaly from the University of Alabama at Huntsville, using satellite data to measure the globe's temperature. This started in 1979, so we only have a satellite record that goes back to 1979. Other records are basically going to be ground-based temperature observations, but this is using a satellite of the lower atmosphere to measure temperature. Some people feel that this is the most accurate way to measure the Earth's temperature, as opposed to ground-based thermometers. That's another discussion. But during the period of time when we went into the solar minimum, the global temperature anomaly, 0 would basically mean there's no temperature anomaly for the globe. If you were to use a 30-year average of temperatures for the Earth and compare that to what was observed. Notice that we have these periods of time where we do get cooler. And if you notice, if we go to the solar minimums of the most recent solar minimum, and let's go back 10 or 12 years, there's another dip. And if we go back to the late 1900s, look, there's another dip. Now the temperatures do rise as we go through these periods of solar maximums. So we do have a temperature relationship globally with solar maximums and minimums. Now, I can guarantee you, you will find climatologists who will completely disagree with that and basically say that these fluctuations have to do with particulates and greenhouse gases. Do your own research, read their arguments, but this is compelling. It really is, and it's really, frankly, hard to ignore these relationships. So using the past as a guide, La Nina is going to persist into January and February. When I'm using the past as a guide is, I'm not looking at computer models. What I'm doing is saying, historically, when we go through these solar cycles, this is when we should expect La Ninas and El Ninos. So the very damaging La Nina that we have right now in the western United States is likely going to persist into January and February. As the solar cycle matures, as we go into the spring season of 2022, we're most likely going to see an El Nino develop. Now, the strength of that El Nino is unknown, and whether or not the spring of 2022 and into the summer of 2022 will be enough to erase the drought, don't know that. But odds are more likely than they're not that the La Nina will end, but it's going to persist a little bit longer. This solar minimum that we went through was very, very strong. And our cosmic ray count is still high, even though we're going into a new solar maximum. So it is likely that the drought conditions in the parts of the West and the central United States will continue into early 2022 before improving. That is just using solar trends as a guide. So let's see what happens. I could be 100% wrong. I may be 100% right or somewhere in between. But these trends historically tend to be good guides, and that completely does not use any computer modeling whatsoever. But it's called analog forecasting. It is using the past to understand what the future might bring. And as I've shown you on these graphs, it's fairly consistent on these 11-year solar cycles. Again, to go back, this is a graphic I showed you earlier. When you have El Ninos and a warmer ocean basin in the Pacific, you're more wet. When you have La Ninas, you're tending to be dry and colder. That's why during solar minimums, if indeed it is cooling the Earth and eventually the waters, and it's cooling those waters more in a solar minimum than during a solar maximum, your La Ninas are going to be more intense. And you get all these bad things. There's really nothing good about a La Nina for Western North America at all. There really isn't. It's a bad situation because it's a drought signature. You still have El Ninos and you still have La Ninas during all of the solar cycle periods, the maximums and the minimums. You can have El Ninos and La Ninas, and you usually do go back and forth. They just tend to be stronger and more persistent during the maximums and the minimums. There's a couple of things I'll point you to if you want to read on your own. Again, I'm giving you two things here that are going to be pro-sun-climate relationship. I'm not giving you anything here that is the opposite. One reason for that is I haven't found anything that is compelling. The arguments I've seen against this tend to be more personal attacks, and they tend to not disagree with the idea or the thought, but a argument, so to speak, that, well, whatever the sun's doing, it's being overridden by greenhouse gases. But The Chilling Stars by Henrik Svenmark is an excellent book. It's actually been out since the late 1990s, but it's a good read. It's a short read. It's a book that laymen can read and get an understanding of the cosmic ray connection, not only going into what's happened in the last 30 years, but going back in Earth's history. And again, that book is not an anti-climate change book. It's just bringing up that connection. Also, this article here, I know this is a long URL for you to pick out, but I really recommend you read this paper as well, because it does go over some of the connections as well, that it's quite compelling.